right? So I've not done the whole sorting stuff myself. Well, I've done this a dozen of times in my own research with other variables. But you don't have to kind of do this all the time yourself if you have kind of a nice data source available. And usually he has data like that goes back to, so there are two cutoff dates. They started the daily return documentation in the USA in 1963. So it's very good data from the 1960s. And then someone went back and typed up all the share prices from the Wall Street Journal, from the paper version, and we have data for some frequencies going back to 26. These are pretty long time series, and the good thing in this database here, that's from the Chicago Research Center and Security Prices, is that it's well kind of maintained. So if people find an error, they report it there and it's corrected. This is, for example, not true in Bloomberg. Bloomberg is very much focused on current data, right? It's important for traders and bankers and people who want to stay up to date, but no one is correcting the mistakes that someone found something that was 2 weeks old, so oh, this doesn't matter anymore, right? That's old stuff. Right, so if you use Bloomberg data or other data sources, it's sometimes not correcting the errors, and that could be a big problem. Right. So this is a well-maintained database. Unfortunately, it's very expensive, so we're talking about 5-digit numbers per year for a university account. And unfortunately, we don't have enough finance researchers to justify that. Justify it just by myself to get like 15,000 euros for a database. Bloomberg is even more expensive. We're talking about $5,000, I think, per month, right, for a single terminal. But if you want to have access to Bloomberg, I think there's one in the university library of Humboldt University or Technical University. I think one of them has it. And I think if you walk into the library, and you should be able to do as students, you can just use it. So that should work. So you should get access to that. Unfortunately, we have just one database that never worked with it. It's called Macrobond. It has more economic indicators in it than individual stocks. But one source of data that you could use, which is free, is Yahoo Finance. You can download everything in a very nice format. And so far, I've not seen many errors in it. Of course, it's kind of manual work to download stock by stock, but it's a free source that you can nicely use for a thesis. Okay, so the first sorting criteria is the beta itself. So we create portfolios with low betas and high betas, and when the beta changes, we reassign. So this here is a graphical representation. I've taken this idea from the book by Ivo Welch. So he looks at how much money do you make if you put $1 US in the portfolio, in each of those two portfolios. The gray line here is the portfolio with the low betas, and the red line is the portfolio with the high betas. Now, what would you expect if the capital asset pricing model was true? Then the high beta portfolio should give you a decent return on exits because it has a higher beta. Right? Now, look at the result. If you put $1 in there, you would have made twice as much as money as with the high beta portfolio if you bought the low beta stocks. So this is dollars. You would have made $300 with the low beta stocks and $145 with the high beta stocks. This kind of turns the prediction of the capital asset pricing model upside down, right? It just says it's the opposite. Like, how did that happen? And you see that there is kind of some patterns in here. So in this area here, actually, the red line is steeper. That means that the high beta stocks actually indeed had a higher return. However, their downfall is kind of much larger here. And you have kind of more movement in the red line, while specifically here, the gray line is pretty stable, right? So yes, you get an additional risk premium in good times, but when the risk actually hits you, you're losing quite a lot, right? Which is literally what high beta means. But on average, you see that the risk premium here does not seem to be, at least, well, it's not a risk premium technically, it's the historical version, right? It sees that it's not a good idea to do. I mean, this is a period of 60 years, right? It's a pretty decent long period, right? Where, I mean, on average, you still made a profit, but making twice as much money with the low beta portfolio than with the high beta portfolio, that is kind of surprising. Just to give you an indication of what the difference in the betas are. So the low beta portfolio has an average beta of 0.67, while the high beta portfolio has an average beta of 1.48. Right, so we're talking about a beta that is twice as high, right, and make half as much money. Right. That really, this picture really destroys the capital asset pricing model very quickly, right? Which is unfortunate. So we would expect that the red line will be above the gray line for most of the part. So this is the data set that starts with the daily prices in 1963, right? So that was the data that's been used here. So let's look at these portfolios in more detail. So now this is in table form. You see, I've showed you this portfolio, that was the gray line, and this portfolio, that was the red line. Right, so we have 5 portfolios, of course. So every column here is the information of one portfolio. So on the in the first row, we have the average returns. Please note that there is this is the arithmetic average. So the picture that you see here is something slightly different. It's the geometric kind of compounding, right? So now this has something to do with kind of how the returns are correlated with themselves over time, right? So this is not contradictory that the average return of the beta portfolio here is smaller than this one. This one just spreads out much more than the low beta return, right? So that's something that we have to take into account, or that we see from the picture. So you can end up with a higher overall return of your investment strategy, even though that the average here seems to be, the arithmetic average seems to be a little bit higher. And the difference is in the computation of arithmetic versus geometric returns. So the picture illustrates the geometric return. Basically, you invest once and hold that for kind of 60 years. And the reason is that these returns you have is much smaller standard deviation than these ones. I haven't put volatility into the picture here, but it's something I could easily compute. You will see that this here does indeed have a much smaller volatility than this one. Now, for every portfolio, I've determined alphas and betas. Right, so the beta difference here is 0.67 to 1.48, and you see that actually our sorting worked, right? So the betas are increasing with my portfolios. Now, there is a very interesting pattern in this so-called alphas, right? So the alpha is basically now a comparison to what is my actual return versus the return that was predicted by the capital asset pricing model. So look at this number here. So this is a positive alpha. And a positive alpha means that my actual return is higher than the one that I predicted. Right? So the consequences that my actual return higher than predicted by the CAPM. So you can, in that way, interpret the alpha as the error of the CAPM, right? The alpha should be 0 if the CAPM is valid. There is no intercept. Do you have any questions regarding the? However, so now this is in right? Now we see that we got 1.86% per year more than the model predicts. And the picture completely flips for the high beta assets, right? So the alpha here is 0, so my actual return is smaller than predicted.